How you doing, ladies and gentlemen? This is Mr. Guy. We're going to kind of do notes a little bit virtually today. So obviously I'm not there today, as you guys know, so you should be listening to this on your iPads and have this note in front of you. Please make sure you are copying these notes down as I go through. That's the whole point of us doing this. Please make sure I'm not on mute. You're actually listening to me, because I'm going to have a little bit of advice for you throughout this and kind of tell you some things that you need to do. This is a big concept on the non-calculator section of the PSSA, the non-calculator section. So please make sure that you are not using a calculator as you work through this today. This is supposed to be something that you try to do mentally. You may have to go back and look at your notes for this today, but these are things that we expect you to kind of start thinking about and maybe memorizing so you know these, okay? So this whole topic today is about square roots. Before we talk about square roots, let's talk a little bit about what it means to square a number. You've probably heard of this before. Okay, but think about a square, and I'm just going to draw a picture of a square here. Think about a square like the shape, okay? And a square has sides that are the same length. All the sides are the same length. And if you go to find the area of a square, you just multiply those sides together. So let's say that this square is a side length of 3. If I wanted to find the area, I would go ahead and do 3 times 3. This is where the term squaring comes from. Squaring is just multiplying a number by itself. It's how we find the area of a square. So squaring a number means to multiply the number by itself. Okay, it's just a fancy way of saying multiplying the number by itself, or it's denoting it with the exponent 2. This means that you're multiplying it by itself. If you remember back when we talked about powers and our exponent laws, okay? So that's kind of where this term comes from. So if you look down here, 8 squared will be written as 8 to the second power. And 7 squared will be written as 7 to the second power. Now, these squaring numbers is really important because what we're going to be looking for are things called perfect squares. Okay, and these, in fact, are the things that you're going to need to know when you're going to take the PSSA and just know in general, okay? A perfect square is a number that happens when a number is multiplied by itself. Now, that might sound kind of silly. You might be like, what? Okay, but a perfect square basically means that when you square root the number, you're going to get another whole number out. Okay, you get another whole number out. So, for example, some perfect squares we can think of, one of them would be 9. 9 is a perfect square because 3 times 3 equals 9. 25 is a perfect square because 5 times 5 equals 25. 100 is a perfect square because 10 times 10 is 100. And 49 is a perfect square because 7 times 7 equals 49. Now, when we look down here, some non-perfect squares, 15, not a perfect square because no whole number times itself would equal 15. Okay, there is no 2 times 2 or 3 times 3 or 4 times 4. 10, not a perfect square. No whole number multiplied by itself equal 10. Can you think of a number that would not be a perfect square? I'm going to use one of my favorite numbers, 7. Is definitely not a perfect square because there is no whole number times itself that would equal 7. I'm going to put kind of ditto marks here, okay? But there is no whole number multiplied by itself would equal 7. The first 15 perfect squares, we're going to list these out, and these are the ones that when you go to take the PSSA, you are going to need to know. They're going to use these and throw these at you. And we're going to do some practice today and tomorrow before kind of our really short spring break on getting to know these and make sure that we really have these down so we know these really well. The first one would be 1 times 1, which is 1. The second one is 2 times 2, which is 4. The third one is 3 times 3, which is 9. Do you guys start to see what we're doing here to get these? The next one is 4 times 4, which is 16. The next one is 5 times 5, which is 25. The next one is 6 times 6, which is 36. The next one is 7 times 7, which is 49. The next one is 8 times 8, which is 64. The next one is 9 times 9, which is 81. And then the next one is 10 times 10, which is 100. There's the first 10. Those 10 you might have been familiar with. You might have had to memorize those in 7th grade or 6th grade. We're going to take it a step further and make sure that we know up to 15, and then we're also going to throw in 20 for some good measure. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And then 15 times 15 is 225. For good measure, we're also going to throw in what 20 times 20 is. These ones right here are not that important, 16, 17, 18, 19. But 20 times 20 is 400. So what we have here is our perfect squares. These are the numbers that when you square root them, you'll get a whole number. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, so on and so forth. That's where these radical signs come in. This is what's telling you to take the square root. The square root of 16 is 4 because 4 times 4 gives us 16. That's kind of our goal here when we're doing this, is that we are looking to find what whole number multiplies to equal whatever is underneath the radical. So when I see the square root of 64, I know that that's 8 because 8 times 8 gives me 64. When I see the square root of 81, I know that's 9 because 9 times 9 gives me 81. And when I see the square root of 144, I know that that's 12 because 12 times 12 gives me 144. Do you think that you can fill in the other 6 of these that are left over? Go ahead and pause the video, take a minute, try to fill in the other 6, and then meet back and check with your answer. All right, here they are all filled in, 8, 9, 12, and then 6, 7, 15, then 5, 10, and 20. Again, these are the numbers that multiply by themselves would give us what's underneath that radical sign. These are our perfect squares, and these are their square roots. Now, we can kind of do this to kind of get us a bunch of different kinds of ways that are going to show it to us, okay? For example, they could throw this symbol right here in front. Don't let that mess you up. What that symbol is telling you is that it can be positive or negative. So the square root of 81 is 9. That would be the positive square root of 81. The negative square root of 81 would be negative 9. So both of these would be answers to this if they gave it to us like this. Plus or minus square root of 169, that could be 13. It could also be negative 13. Okay, so that's kind of what's going on with these problems. If you see this plus or minus symbol in front, you are supposed to go ahead and do the plus or minus and solve for what that's supposed to be. Even though we don't have to memorize the ones between 15 to 20, we do have to use some context clues to help us out and figure that out. 256 right here is not one of the ones we have to memorize. However, I'll tell you guys that that one is equal to 16. So 16 is the square root, or negative 16 if you want to go ahead and include the negatives. Okay, if you see a negative out front like this, you go ahead and you make sure that your final answer is negative. So negative out front, negative 13. Negative out front, negative 16. And again, this is our generic one over here where we're just going to go ahead and write 9, 13, and 16. We don't have to do anything special when we see it like this. Now, if there is a negative underneath your square root, what happens to that? If you guys want to go ahead and try doing that in a calculator right now, you might be shocked about what happens. You go ahead and square root negative 16, you're going to see your calculator give you an error. That's because this has no solution, at least not currently. When you go ahead and you take Algebra 2, you will talk about how to square root negatives because you actually end up with what we call an imaginary number solution. Yes, that's right. Math gets even weirder. You deal with imaginary things, things that aren't real. Okay, so this has no solutions. At least we're going to add a little caveat here. No real solutions. You will find out later about what the imaginary solutions are for this one. Okay, but anytime a negative is underneath the radicand, underneath that square root symbol, that's going to be no real solutions. Whereas up here, you can see it's out front. That's okay. It just makes our answer negative. Fractions tend to throw people off. They see this and they go, oh my gosh, just these fractions, what it's supposed to do. It is as easy as doing it when it's not a fraction because you can rewrite it as a square root of the top number over the square root of the bottom number. And then you just square root each of those. The square root of 49, oh yeah, that's 7. The square root of 64, oh yeah, that's 8. There's my answer. You just square root each one individually. So this one, the square root of 121 is 11. The square root of 289 is 17. 11/17. There's my answer. The square root of 1 is 1. The square root of 225 is 15. 1/15. There's my answer. So all you have to do is square root the top and the bottom separately like this, and you get your answer with a fraction. Last but not least, we have what happens when you're given a decimal. This will not come up super often, but basically what you want to do is you just want to kind of take the square root and then put the decimal place where it goes. So for this one, we have 0.49. That's going to be 0.7 as your answer, 0.7. This one's 0.81. That means 0.9 is going to be your answer. Okay, 0.9. This one over here is a little bit weird. We have 0.0121. Okay, so when we go to square root this, 121 we know is 11. 0.11. 0.11 is going to be our answer. Just in general, be a little bit careful with these. Make sure that you have those decimal places where they're supposed to go. And that's really it, guys. That's kind of the big thing with square roots here. Hopefully you have a full note sheet filled out. You should see some homework problems for you to do. And make sure you get those done in a reasonable amount of time and you try on those. And if you get done early, there's going to be some IXLs assigned to you, but also you can start studying and memorizing these square roots. This list up here that we wrote out of our square roots, 1, 4, 9, 16, 25, 30, all that. You need to memorize these. You need to know these. Okay, if you do not have these memorized, it is going to come back and hurt you when you go to take the PSSA. So please make sure that you memorize these, all right? Thank you guys for watching. I hope you had a good time.